Okay, in today's class, we shall be looking at the concept of conversion of units. Conversion of units in physics is something very important that for you to do well as far as calculation in physics is concerned, then you need to be very sound at it. It's very important you know how to convert from one unit to another. And knowing fully well that all units are to be converted back to the fundamental unit. It's very important you know the relationship between one unit and the other. A lot of schools, including Lagos State curricula, we have issue with the time given to treat this particular topic, measurement and units. And because of that, there's no time for teacher to be able to cover how to convert from one unit to another. I never can tell. Maybe it was assumed that you understand how to do that right from the primary school. Only God knows. So, but as far as this class is concerned, we are going to get started now by looking at how to convert from one unit to another. So, we are going to call the topic unit conversion. Now, it is very important you understand the relationship between one unit and the other. And for you to easily remember or to easily understand, I would like to categorize all we are going to be doing today to be a fundamental quantity. That is, I'm going to consider the fundamental quantity mass, length, and the third one is time. Now, there are some quantity related to mass, such as weight, and there are some quantity related to length, such as distance and volume. So all of these are what we are going to be considering to know the whole of the units that exist, the type of units that exist under mass, the type of units that exist under length, the type of units that exist under time. Knowing all of these units and the relationship between them is what will guarantee us to convert from one to another. And lastly, we are going to remind us of our metric system. Metric system is very important. So, without any further ado, let's get started. So, I want to start with the very first one. So let me clean this and start from the aspect of mass. So when you talk about units related to mass and weight, we have the following. We have that 1 kilogram is equivalent to 1,000 gram. We have that 1 kilogram is equivalent to 2.204 pounds. We also have that 1 ton is equivalent to 2,000 pounds. And we have that 1 metric tons is equivalent to 1,000 kilogram. And you can also see 1 metric tons is equivalent to, sorry, this is supposed to be 1 metric ton, not tons. So let me clean the S. Yeah. Okay. So 1 metric ton is equivalent to 1000 kilogram, and 1 metric ton is also equal to 2204 pounds. So here are the units related to mass and weight. Normally, pounds is strictly for weight, but at times we convert mass to weight, because though mass and weight are not the same thing, because mass is the quantity of matter present in the body and weight is the gravitational earth pull on a body. Now, for you to do conversion from one unit of mass to another, there's need for you to master all of this relationship. Okay, so let's move to the next one. So the very next one that we want to look at is going to be that of length. So we'll have units related to length and or distance. Now, what are the units related to length or distance? So knowing this would also help us to be able to convert from one to another. So the very first one that I would like to put down here is the one between meter and kilometer. So if I have 1000 meter, this is equivalent to 1 kilometer. If I have 100 centimeter, this is equivalent to 1 meter. If I have 1 mile, this is equivalent to 1.609 kilometer. If I have 1 mile, it's also equivalent to 5,280 feet. If I have 1 feet, this is equivalent to 12 inches. 12 inches. And if I have 3 feet, this is equivalent to 1 yard. If I have 1 inch, this is equivalent to 2.54 centimeter. Now, these are the units that relate to length, or what we can call distance. Now that you understand this, you should be able to convert from one to another. Knowing how to convert from one to another is what really make your work so easy. Let me add one to this. So reason why I'm not putting it is because it's damn too small. So 1 centimeter is equivalent to 10 millimeter. Do you understand this now? So master this. Once you master all of this, converting from one unit to another is not going to be a problem. Okay, so the next one is units that relate to length, and I talk about volume. So this is a quantity that is related to length, just like distance. So volume, or you call it capacity. Remember, it is length cube. That's why I said it is related to length. Okay, so if that should be the case, let's see the units that we can find under volume. Some of the units that we can find under volume include liter. So 1 liter is equivalent to 1000 milliliter, and 1 milliliter is equivalent to is equivalent to 1 centimeter cube, and 1 meter cube is equivalent to 1000 liter, and then 1 gallon is equivalent to 3.785 liter, All of these you just need to memorize them, and the only way you can remember them is by solving questions with them. So 1 gallon is equivalent to 3.785 liter. Also, 1 gallon can also equal to 1 quart out there. So 1 quart is equivalent to 2 pints. So, okay, if you are Yoruba, you just see that Yoruba always call paint. It is not paint, it is pint. I get this now. So 1 quart is equivalent to 2 pints. Now you need to understand this one also, because one of the problem that makes students fail physics calculation question more, especially under gas, is as a result of not knowing how to convert units of volume. When you have it in milliliter, how do you convert it to meter cube or centimeter cube? It's very important you understand all of this very, very well. So you can get a book and put them down and practice with them regularly. All right, so let's move to the next one. And that next one, I think that should be time, because we are talking about the 3 fundamental quantity in science. All right, so the next fundamental quantity in science is time. And when you talk about time, time is the duration of an event. So what are the units associated with time? We have that 1 hour is equivalent to 60 minutes. And then 1 minute is equivalent to 60 seconds. And then 1 day is equivalent to 24 hours. And then 365 days is what make 1 year. And then we have that 30 days is equivalent to 1 month in most of the calendars. 1 century is equivalent to 100 years. And 1 millennium is equivalent to 1,000 years. So all of these are very important for you to note. But I want to call your attention to something. Should, in case you are dealing with a critical aspect of physics, that every decimal place counts, then you need to be very careful of the numbers of days that makes a year. That is, normally 365 days is what make a year. But when you consider the leap year, which is 366 days, that is the year in which February is going to up to 29. You know, most years February is 28, but every 4 years February used to be February will be 29. Are you getting this now? So if we are to consider that, then when putting down 1 century, which is 100 years of a thing, if you really want to get the numbers of days that make a year, then you have to consider the fact that for every 4 years, that is when leap year occurs. So you have to factor in leap year into what you want to do, and for that reason you are going to go by the average of that 4 years. That is 365 days plus 365 days plus 365 days plus 366 days divided by 4. So whatever results you have here is what you are going to be using, and I think that should be around 365.25. So although it's not really significant, I'm not sure of this value, but try and check what you are going to have. But I think it should be this. So if you look at this right now, 365.25, this is supposed to be the normal conversion. So it means 365.25 days is what is going to make 1 year. Am I making sense now? So in some calculation, you need to typically use this. For a normal calculation, just go by directly by saying 365 days. The decimals will not really count. But in some cases, like what I said earlier, the decimal is strictly significant. All right. So those are the conversion units for all of these quantity in science. That is the three fundamental quantities in science. That includes mass, length, and time. So being able to look at those three, and I said we're going to wrap it up by looking at the metrics. Now, as you grow in physics, like that is, by the time you get to SS1 second term, like you are now, by the time you start doing some topics, you will start getting familiar with some metrics that you probably did not get familiar with before. For example, micro, pico, nano. You know, we get to know about nano because of the seam that we are cutting in the real life. We got to know about micro because of the seam that we are cutting in the real life. And you know, when a plumber works for you, the capacitor, normally capacitor is supposed to be measured in microfarad. That is all the small capacitor that we are buying. They are all in microfarad. Are you getting this now? But if a layman, that is a plumber, wants to call it for you, is going to pronounce it as UF instead of microfarad, to tell you that we are not really familiar with all of these metrics, including you as a student. So that is the reason why I would like to include it in this particular class and use this to wrap this up. So metric system, when you talk about the metric system, is very, very important. We know that. So let's start from the very small ones. Metric system. All right, guys. So the very first one we are going to look at is going to be deci. So decis is just what 10 raised to power minus 1, and the abbreviation is D. So if I have 5 decimeter, so 5 decimeter simply means 5 multiplied by 10 raised to power minus 1. Are you getting this now? And that means 0.5 meter. You understand this now? That's what deci simply means. All right. So what's the next one after deci? It is centi. So centi. And that's 10 raised to power minus 2. So what does that mean? And the symbol is C. So if I have 10 centimeter, that's equivalent to that's equivalent to 10 multiplied by 10 raised to power minus 2 in meter. You understand that now? So I'm replacing the C with what? With the value 10 raised to power minus 2. And this is just going to give us 0.1 meter. So do you get this now? All right. So what's the next one now? The next one is milli. Milli. So this will give us 10 to minus 3. Are you getting this now? Milli is 10 raised to power minus 3, and that can be written with small letter m. Are you getting this now? So that's small letter m. So what's the next one after milli? It is micro. Micro. So micro is 10 raised to power minus 6, and that is denoted with mu. Mu is a Greek symbol. How do you know? That we used to represent micro. So the next one is nano, and that is 10 to minus 9, and the symbol is small letter n, and we have the very last one here, which is pico, and that's 10 to minus 12, and the symbol is p. I want you guys to understand something about this. We always use this unit very well in a case whereby we have a very small amount of value. You know, a situation whereby you have 0.00000. How many zero is this? 1, 2, 3, 4, 5, 6, 7. Okay, let's say okay, let me put 8 here, and you have column. So if you look at it, if I can't, if I just shift this backward now, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let me add 1 0 to 8 to make it 9. All right, so this is 9 now. You can see this value, if I want to write it in column, it's not really going to make sense because it's just too small. So in order for me to write it in a decent way, I'll just write it as 8nc, and this is just what, 8 nano column. Are you getting this now? So, and at times I can have a value that is very, very small for like something like this. 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let me say 2 farad. I have a capacitor that is this small in value. So for me to write it in a decent way that will really make sense, I'll write it as 2 picofarad. Are you getting this now? So basically, all these metrics, they are used to what? To write small value. It's the value that is very, very small. So you use all of these metrics to write it in a decent way. Is that taken now? All right. So the very next one we want to look at now is although there are some other metrics aside from this, but the relevant ones is just these ones. So there are other ones. So you can just learn that one for knowing sake. Are you getting this now? It's not really important for you to know those ones, but just for extra knowledge sake, that you can do. But as far as physics is concerned, you are good to go with this. But probably if you're now doing some courses, probably you want to specialize on unit or something, then you might need all of those ones to survive in such exam. But as far as Jamb is concerned, Waec is concerned, GC is concerned, this is okay for you, including your university exam. So down to Pico is just very nice. All right, so let's look at the next metrics. That is, what if a number is very, very big? If a number is very, very big, you know, we have considered if a number is small, that's the metrics we look into now. So if a number is very big, how do we do that? Okay, we go by the first, like, if it's very, very big, let's start from the one that is considerable, like within us, the one that we can really see, tera. So when you talk about tera, we have 10 to power 12, and the symbol is just capital T. And we have giga, and the units of that is 10 to power 9, and it is denoted with G. And we have mega. The unit of this is 10 to 6, and it is denoted with capital M. Then we have the next one, which is kilo, and that is 10 to power 3, and that is capital K. And the next one is hectare. Hectare, we have it to be 10 to power 2, and that is the symbol is H. And the next one, which is a very smaller one, that is the last one we're going to consider here, is deca, and that is 10 to power 1, and we are going to be having it to be DA, so DA, deca. So these are the units to express values that are very, very big. For example, if I have 12, 0, 0, 0, 0. So if I have a value like this, are you getting this now? So instead of me to write this so long like this, maybe is in Newton. For example, Newton. I'm just going to write this as 12 tera Newton. I'm missing this now. So 12 tera coulomb. And you say, and it can be another number entirely. For example, let me say I have 7 gigawatts. Now, if I have 7 gigawatts, what does that mean? It means I'm having 7 billion watts. 7 billion watts. So instead of writing the 7 billion watts, I'll just write it as a decent unit, 7 gigawatts. So all of these are the conversion units that you need to know as a student of physics. Now, knowing all of this is not enough, like knowing how to apply them in a question. So if you just cram all of this one, it's not going to be of use to you. It's not going to be what? Of use to you. If you cram all of this and you don't know how to make use of them. So in order for us to start, there are some units that they are just one-step conversion. Are you getting it now? They are one-step conversion. And what do I mean by one-step conversion? That is, the units you are converting from to where you are converting to, there's a relationship between them. For example, if I say convert 300 gram to kilogram. So this is one step. Why? Because there is a relationship between gram and kilogram. So what will I just do there? I'll just say recall, that is, you are recalling somewhere, probably on your head or at the back of your book. Are you getting where I'm coming from now? That, what do you want to recall? You want to recall that 1000 gram is what equivalent to 1 kilogram. That is basically what you want to recall. So if that is the case, how can I convert from gram to kilogram? So all it just needs to do is to write down 300 gram and put equal to here, or better still, you can just put multiplication here. You will always be multiplying by fraction. But what fraction? So you come down to this place. You see, 1000 gram is what equivalents to 1 kilogram. So the question is, which one will be at the denominator and which one will be at the numerator? So this is gram that we want to cancel, right? So you check if gram is at the denominator, is it going to be able to cancel this? So if I have gram here, I should be able to cancel it because this one is over 1. So gram and gram will definitely cancel. So what's the coefficient of gram here? 1000. So you have that 1000 gram is going to be at the denominator. And what is the unit you are converting to? Kilogram. So you have 1 kilogram here. So that this gram and this gram can cancel. Can you see that now? So 20 can cancel this 20 here. So you therefore have 3 times 1 kilogram. That will give you 3 kilogram divided by 10. So 3 kilogram divided by 10, that's 0.3 kilogram. So you can see the way we are able to convert from gram to kilogram. So this is just a step conversion. Are you getting this now? It is a step conversion. So let's consider another a step conversion. And that is if I have something like, let's say 0.55 liter. If I have 0.55 liter and I want to convert it to milliliter. So there is a conversion unit that relates liter and milliliter together. So that is what you just need to recall somewhere, maybe on your head or in your book. So as it is at the back of your book, it's not necessary it should reflect in your calculation. So you ask yourself, what's the relationship between them, between liter and milliliter? Of course, if you have notes all these things down, you get to see that that will be under volume, right? And you have that 1 liter is just equivalent to 1000 milliliter. Are you getting this now? So 1 liter is equivalent to 1000 milliliter. So the question now that you need to ask yourself is, which one is going to be at the denominator? Which one is going to be at the denominator? So you write down 0.55 liter. Remember, liter is what we want to cancel. Am I making sense now? So draw your fraction line. If you draw your fraction line, which one is going to be at the denominator? So because I want to cancel liter, so liter has to be at the denominator. So I have 1 liter here, and then milliliter will be at the numerator because that is where I'm converting to. I'll therefore have 1000 milliliter here. So if liter cancel liter, you have that 0.55 to be multiplied by 1000 milliliter. And what will this give us? 550 milliliter. So do you understand this now? So 550 milliliter is going to give us 5,000, sorry, 0.55 liter is going to give us 550 milliliter. I believe you understand this. Okay, so if you understand this now, let us clean this and look at another example of one-step conversion. All right, so another example of one-step conversion that we can consider to look into is, let's take for example, I want to convert from kilogram to gram. I've considered that before. Let's say I want to convert from kilogram to pounds. So converting from kilogram to pounds, how will I go about that? Let's say I have 4 kilograms and I want to convert it to pounds. So 4 kilograms to pounds, how should I go about that? So the next thing to ask yourself is, what is the relationship between kilogram and pounds? So you come down to this side and put it somewhere like this. So you have that 1 kilogram is equivalent to 2.2 pounds. So 2.2 pounds is equivalent to 1 kilogram, right? So you write down 4 kilogram multiplied by your fraction line. So kilogram is what you want to cancel. It's going to be at the denominator. And 2.2 is where you are converting to, which is the pound. So kilogram, we cancel kilogram. You therefore have 4 multiplied by 2.2 pounds. Now, I know somebody just want to tell me now that it's supposed to be 2.204. But why I decide not to consider 04 is because it's not really significant. And that's why I just take it to what 1 decimal place. So if that should be the case now, I'll just say 4 multiplied by, so you can also help me with your calculator, 4 multiplied by 2.2, that should give us 8.8 pounds. So 4 kilograms is equivalent to 8.8 pounds. So do you understand that now? All right, so let's move on to two-step conversion. Now, when I say two-step conversion, what does that mean? So when I say two-step conversion, what does that mean? What it means is that there is no direct relationship between the quantity you are converting from and the quantity that you are converting to. So there's need for you to pass through an intermediary between the two. Let's take for instance that somebody say convert. So somebody asks us to convert let's say 5 yards to inches. So we're asked to convert 5 yards to inches. How do we go about that? Is there any direct relationship between yards and inches? So we need to think about that. Do we have? Not really sure. But we have the relationship between what? Yards and then feet. And we have relationship between feet and yards. So let's quickly look into that. We have that 3 feet is what equivalent to 1 yard. And we also have, secondly, that 1 feet is equivalent to 12 inches. So remember, we are going from yards to inches. So we need to first of all get to feet before we can get to yard. So that is what we refer to as two-step conversion. So 5 yards multiplied by what fraction? So we have 3 feet equivalent to 1 yard, right? So it is yard that we want to convert. Are you getting this now? We want to cancel yards. We want to leave it for feet. So we have that 1 yard will be at the denominator, and then feet is going to be at the numerator. That is 3 feet. Then multiply by, so if you convert to feet now, you want to what? Cancel feet also to convert to inches. So let's get another fraction. That's why we call it what? Two-step conversion. So this will now become, feet is what you want to convert here. So we have 1 feet to be at the denominator, and we have what? 12 inches to be at the numerator, since that is where we are going. So we can now start by saying yard cancel yard, feet cancel feet. So we therefore have 5 multiplied by 3 multiplied by 12 inches. So your result is going to be 5 times 3 is going to give us 15, and 15 times 3 should give us 15 times 12 rather. 15 times 12 should give us 180. Yeah, so we have 180 inches. So 180 inches is equivalent to 5 yards. So that is two-step conversion. So you can see we have to convert to 1 unit before we can get to the exact unit that we are going. So it happens like that at times, and that's why you need to master this very well. You can create a problem for yourself on it, then you are good to go. Now let's move a bit higher. We are dealing with a linear number since morning. Let's try, what if we want to convert a area? We are dealing with conversion of length since. What about conversion of area? Conversion of area can be tedious, and that is why you need to pay attention, especially if you are dealing with questions under electricity. For example, under Ohm's law, when you are given the length of a conductor, you are given the resistivity, you are given the area, most of the time the areas are always in millimeter, because the area of the wire that you have inside there, a conductor, that is all those copper wire that you have inside your maybe 5 mm wire, their diameter is very, very small. So having a very small diameter is going to result to having a very small area. So for that reason, it is always best to express in what? In millimeter. I get it? But you cannot solve in millimeter because you want a fundamental unit to be your final answer. So there's need for you to convert to meter. So let's see how we can convert area, how we can convert volume. Okay? So let's take for instance that I have what's it called? If I have let's say I'm thinking of the value that I can see we have. Okay, let's say I have 12 centimeters square. For example, I have 12 centimeters square and I want to convert it to meter square. It's very important to note now. I'm having 12 centimeters square and I want to convert it to meter square. So this is area conversion. And how do I go about it? So the way I go about it is that I'm going to ask myself, what is the relationship between centimeter and meter? So you write it down somewhere here. And you have what? You have that 100 centimeter is what equivalent to 1 meter. So if 100 centimeter is equivalent to 1 meter, I have 12 centimeters square here. Multiply by, so you draw your fraction, just like we did with linear. So which one will be at the denominator? We want to cancel centimeter, so centimeter should be at the denominator. We have 100 centimeter here, and then 1 meter will be here. But you know what? This is centimeter square. What can we do to have centimeter square here? We then square both numerator and denominator. Are you getting this now? So that will let us have 12 centimeters square multiplied by 1 meter square all over 10,000 centimeters square. Do you understand this now? So by squaring both numerator and denominator, we are able to have centimeter square at the denominator, so that centimeter square will cancel centimeter square. We therefore have that 12 multiplied by 1 meter square, that will give us 12 meters square divided by 10,000. Can you see that now? So if we have this, what will now be the result? Okay, so our result here is going to become 0.0012. So if I take this backward, now I have 1, 2, 3, 4. So this is in meter square. So do you understand this now? So that is how to convert it's the area. So when you are converting area, this is how to go about it. So you just have to I believe you understand it, so don't let me say much here because of time. All right, so let's look at volume conversion now, and I think after that we can then call it a day, because once you understand how to convert all of this, they are good to go with any other type of conversion. All right, so let's look at this. Let's say I have okay, let me use let's say I have 3 millimeter cube. You know, that is damn small. Yeah, very, very small. And I want to convert it to meter cube, for example, because this is what usually happens in most cases. Or let me increase this value a bit. I think it's damn too small. Let me say I have 300 millimeter cube. Let's say I have 300 millimeter cube. And I want to convert it to meter cube. So how do I do this? All right, the first thing you should know is that there is really no direct relationship between millimeter and meter. So we have 10 millimeter is equivalent to 1 centimeter, and we have 1 centimeter, sorry, we have 100 centimeter to equal to 1 meter. That's to tell you that there's need for us to first convert down to centimeter, then from centimeter we convert to meter. I know somebody is about to say something right now, and the person wants to tell me that 1000 millimeter is equivalent to 1 meter. Yeah, so it's because you have been solving, that's why you get familiar with this, or because this is not part of the matrix. Is that taken out? So we don't have direct metrics from millimeter to meter, but because you are familiar with probably you have been using it in class before, and that's how you thought of this. So converting from millimeter to meter is 2-step conversion, not just 1-step conversion. All right, so how do we go about this now? So let's take this one down to centimeter, then from centimeter we get to what? Meter. So this will be 300 centimeter cube over 1 to be multiplied by what will be at the denominator is going to be centimeter. So how many centimeter are we talking about? Okay, so 10 millimeter is what gives us 1 centimeter. Okay, so we are talking about 1 centimeter. I think I've made a mistake. It's supposed to be 300, sorry please, millimeter cube multiplied by, so millimeter has to be at the denominator, and that will be 10 milliliter, and centimeter will be at the numerator, then multiply by, we now want to convert from centimeter to meter, so meter will have to be at the numerator, so 1 meter here, and we have 100 centimeter here. All right, so if you look at this, this is cube, right? So it means we have to cube every individual of this also, and this will be 300 millimeter cube multiplied by 1 centimeter cube divided by 10 raised to power of 3 is going to give us 1000, right? So that's 1000 millimeter cube multiplied by 1 meter cube divided by 100 raised to power of 3. So that will be 1. Okay, that's 1 million. Yeah, so that was 1 million centimeter cube. All right, so this is what we have right here. So that's millimeter cube would cancel millimeter cube, centimeter cube would cancel centimeter cube. I will therefore have 300 meter cube divided by 1 billion, sorry, this is 0. So 1 billion. So this and this would cancel. I therefore have 3 meter cube divided by, this is going to give us 10 to the power of 7. Yeah, that's 10 million. All right. So if I'm going to write this now, I can write this as 3 times 10 raised to power minus 7 meter cube, because writing that lengthy 0 is not going to make sense. So this is going to give us 3 times 10 raised to power minus 7 meter cube. So that's how to go about your conversion. So you've known how to convert length, you've known how to convert area, and now you know how to convert volume. So basically, that is how we convert from one to another in pieces. Thank you, guys.